Hello students, how are you? Students, in the previous two lessons, we have learned about temperature and heat. I hope you know the difference between temperature and heat. Today we are going to discuss about new chapter, that is Unit 7. It is about sound. Here we have introduction part. Let me see first. One of the most commonly observed phenomena in nature is sound. You hear different sounds throughout the day. For example, the sound of car, barking of dog, your friend chatting, your family talking, your teacher talking, and so on. These are examples of sound. Okay, students, have you tried to play guitar or crowd? Assume that this one is a crowd. Here we have some strings. We have some strings. These are strings. Strings of the crowd. When you strike the strings, each string starts to vibrate. As a result, you hear musical sound. The vibration travels from each strings or crowds in all directions as a wave. So we call it sound wave. That is sound wave. Students, are you following me? Good. So sound is a form of wave. It is a form of wave. If your ears are around the path of the wave, you can hear the sounds by your eyes. So we can say that sound is a form of wave. Now, based on the above explanation, we can define sound. What is sound, students? Let us define together. Sound is a form of energy. It's generated by a series vibration of an object. It is generated by a series vibration of an object. Vibration means, when you say vibration, it is displaced motion of an object, which means the object move to and fro, back and forth, and so on. So sound is it generated by series vibration of an object. Every source of sound are in a state of vibration. If there is no vibration, there is no sound. And the other point is production of sound. All sound are produced as vibrating objects. As I mentioned before, every source of sound is vibration. So all sound are produced by a vibrating objects. The production of sound travels in every direction in the form of energy or in the form of wave. For example, students, you hear the bell sound in your school, or the bell sound in your school is heard anywhere around the bell or around the school. So the produced sound travels in every direction in the form of energy. So we can say that sound travels all direction and around the corner. Now the next point is transmission of sound. Sound need material to transmit. The material through which the sound traveled and reached your ears is called medium. Media is the plural form of medium. So students, solid, liquids and gaseous state can transmit sound through them, because every substance has in the state of these three states. Now look, showing transmission of sound through the liquid. As I mentioned before, sound can be transmitted in liquid. This one is a bowl of water. To observe sound travel in liquid, we put here alarm clock on the bottom of the water and press the alarm clock by your finger. Outside the bowl, you can hear the sound, because sound can be transferred or transmit in liquid. All material can be transmit sound, but the degree is not the same. Sound is better transmit of sound than liquid and gas, and also liquids are better transmit of sound than gas. Sound need material or medium for transmission. It cannot travel through vacuum. What does it mean vacuum means? Students, what is vacuum? Okay, students, let us discuss together. Vacuum means it is completely empty, or a space without air. So, sound cannot travel in vacuum. If there is no air, the sound cannot travel. Here we have Belgian experiment. This one is a bell jar. In the bell jar, we have clock, that is alarm clock. In the bell jar, there is air inside the bell jar. When the bell is ringing, you can hear the sound of bell outside, the sound of clock outside the bell, because there is air inside the bell. But look at this one, students. When you pump the air by using vacuum pump, there is no air inside the bell jar. So, do you think you hear the sound outside the bell jar? You are right. No, we cannot hear the sound, because there is no air inside the bell jar, and there is no material or medium carrying sounds. So we cannot hear clock, alarm clock outside, because there is no air inside the bell jar. Now the next point is speed of sound in different media. The first one is speed of sound in air. During the thunderstorm, you know about thunderstorm? It's occur in rain season. You may see distant lightning flash some second before you hear the thunder. This suggests that the speed of sound is much less than the speed of light. You know that the speed of light in air is around 300 million meters per second square. But the speed of sound in air is about 331 meters per second at 0 degrees Celsius. The speed of sound increased by 0.6 meters per second for every degree Celsius increase in temperature. Listen be careful here. Now, the speed of sound in 0 degrees Celsius is equal to 331 meters per second square. 300 meters per second. When the temperature is increased by 1, that is 1 degree Celsius, and also the speed of sound increased by 0.6 meter per second. That is, in 1 degree centigrade, the speed of sound is 331 meter per second plus 0.6 meter per second. That is 331.6 meter per second. You see, students, if the speed of sound increased by 0.6 meter per second for every degree Celsius increase in temperature. For example, you can take also 2 degrees centigrade or 2 degrees Celsius here. So the speed of sound increased by twice of 0.6, that is 1.2. So at 2 degrees centigrade, the speed of sound is 331 meter per second plus 0.6 meter per second. This one is at 1 degree centigrade, and also plus 0.6 meter per second. So we can add this one, that is 1.2. 1.2 plus 331 is equal to 332.2 meter per second. 332.2 meter per second. This is the speed of sound at 2 degrees centigrade. So we can calculate at any temperature the speed of sound. The speed of sound in air, any temperature, that is Vt, can be calculated. Vt is equal to Vo plus 0.6 meter per second over 1 degree centigrade times temperature. Here, where Vt is the speed of sound in air at any temperature, and Vo is the speed of sound at 0 degrees Celsius. This one is temperature. Let me see by example. Example. What is the speed of sound in air at 30 degrees Celsius? Please, students, try to this example. I will give you 1 minute. Okay, students, have you tried? Let us do together. Now our given is temperature. Temperature is equal to 30 degrees Celsius. And also we know about initial sound speed of sound, that is Vo. Vo is equal to 331 meter per second. Our required is speed of sound at 30 degrees Celsius. So our speed of sound at 30 degrees Celsius. Now solution. Speed of sound at any temperature, which means at 30 degree, is equal to VO plus 0.6 meter per second divided by 1 degree centigrade times temperature. We have here speed of sound at 0 degree centigrade and also temperature that is 30 degrees Celsius, so we can calculate by substitution. VO, or VO is, or speed of sound at 0 degree is 331 meter per second plus 0.6 meter per second over 1 degree Celsius times our temperature is 30 degrees Celsius. Now degree Celsius cancel by degree Celsius. 0.6 times 30 means that is 18 meter per second, because we cancel degree Celsius here, plus 331 meter per second. 331 meter per second plus 18 meter per second is equal to 349 meter per second. Do you see, students? The speed of sound in 30 degrees Celsius is 349. 349. Now I will give you another example here. A thunder was heard 4 seconds later after the lightning is seen. If the distance of the lightning is 1,396 meters away from the observer, what is the speed of sound at that temperature? Okay. Look, here we have one observer, that is human being. Here there is a light. The distance between the observer and the light is 1,396 meters, and the observer see the light, and also after 4 seconds he hears the sound. He hears the sound. So our given is that is distance. Distance is equal to 1,396 meter, and also there is 4 second time. Our time is 4 seconds. Our required is V, or speed of sound. Solution. You know that this diagram, students, do you remember this one? Here we have distance, here V times T. So our required is V, so V is equal to S over T, or speed is equal to distance over time. Here we have distance, and also here we have time, so we can substitute easily. Our distance is 1,396 meters, and our time is 4 seconds. So our speed is, that is 349 meters per second. Is it clear, students? Very good. Now I will ask you one question. At what temperature the speed of sound is 349 meters per second? Please try it. You are right, students. At 30 degrees Celsius, the speed of sound is 349. We have done before. Now the next point is speed of sound in various substances. Speed of sound in liquid and solids is not affected by the temperature. But you know that the temperature is affected speed of sound in air. But it is not the same true in liquid and solid. But they are affected by their body structure. As you see on the chemistry lesson, the structure of a substance, there is different structure, have different substance. So the speed of sound depends on the structure of the substance. The transmission of sound in different substance depend on the structure of the particle in the substance or the molecule in the substance. Look here, students, please. The speed of sound in water is greater than the speed of air, and its speed in steel is greatest of water and air. The speed of sound in various substances. Look at this table, please. Now here we have substance and the speed in meter per second. That is, the temperature is 0 degrees Celsius. Here we have three states. One is gas, and the other one is liquid, and the other one is solid. In gas, we have two gases, that is oxygen and air. Students, you know the difference between oxygen and air. It's a combination of gas, but this one is one gas. So the speed of sound in oxygen is 316 meters per second, and the speed of sound in air is 331 meters per second. Here we have liquids, ethanol, mercury, water, and seawater. The speed of sound in ethanol is 1,150 meters per second, and the speed of sound in mercury is 1,438 meters per second, and the speed of sound in water is, this water is pure water, 1,410 meters per second, and in seawater the speed of sound is 1,450 meters per second. Here also we have solids, lead, copper, glass, steel, and the speed of sound in lead is 1,948. The speed of sound in copper is 4,998 meters per second, and the speed of sound in glass is 5,628 meters per second, and the speed of sound in steel is 5,948. Look here, students. Now, the speed, all the speed of sound in liquid are greater than the speed of sound. The speed of sound in solid are greater than the speed of sound in liquid, and the speed of sound in liquid are greater than the speed of sound in gas. Okay, students. Now let us summarize the daily lesson. The first one is definition of sound. Sound is a form of energy. It's generated by serious vibration of an object. When you say vibration, as I told you before, vibration is disturbance of motion of an object or to and fro motion of an object. So this one is the definition of sound. And the other one is production of sound. Sound produced by vibrating of an object. Every sounds can be transmitted in all direction. And the other one is transmission of sound. Sound can be transmitted by material or medium. Sound transmitted in solid, liquid, and gas. But the degree is not the same. Solids are better transmitter of sound than liquid and gas. And also liquids are better transmitter of sound than gas or air. And sound cannot be transmitted in vacuum because there is no air in vacuum. So if the transmission of sound or sound must be used material or carrying to transmit one part or another part. And the other one is speed of sound in different media. Speed of sound in different media. Speed of sound in air. Speed of sound in air is 331 meter per second at 0 degree Celsius. Don't forget it, student. It is depend on the degree or the temperature, because when the speed of sound, the temperature is increased, the speed of sound is also increased by 0.6 meter per second. And the speed of sound in liquid and gas is not depend on the temperature, but it is depend on the substance, particles of the substance. This is all about the summary of our daily lesson. Now, students, I will give you homework. Here we have 3 questions. One is, what is sound? The second one is, how sound energy is produced and transmitted. This is 2 questions. The first one is, how is sound transmitted? And the second one is, how is sound produced? And the third one is, what is the speed of sound in air at 40 degrees Celsius? This is all about our daily lesson. Please, students, do this homework and we will see in the next period. The next period is reflection of sound, that is about echo. Please ready on that lesson and we will see on the next time. Thank you for watching. Bye bye.